factor x squared plus 6x plus 8? That's x plus 2x plus 4. Okay, so we've done step 1. Now we move on to step 2. If you haven't watched the video, you might want to go back and do this. I'm going to talk about it, but I've assumed you've watched. Do you have any repeated factors, x plus 2, x plus 4? No, they're both different, so skip that bullet point. Are your factors linear or quadratic, x plus 2, x plus 4? Both linear. Therefore, your numerator, when you break them up, is going to be a constant value. So it won't have an x in the numerator. And we usually use capital letters. And you got to pick a different constant for each factor in the denominator. So this would break up to be a over x plus 2 plus b over x plus 4. If you have them swapped, that is okay. Okay, you never have to worry about like which one should be first. What would happen is if you wrote it a over x plus 4 plus b over x plus 2, my a is your b, vice versa. But when we write those numbers in at the end, it'll look like the same answer. So you can't go wrong with choosing like which letter goes on top of which. Okay, what would you do first to factor the second one? Take out the x, so you're left with x squared minus 2x plus 1. And then after you factor once, like just double check, does anything else factor? Can you factor x squared minus 2x plus 1? Yeah, its factors are x minus 1 times x minus 1, which could be written as x times x minus 1 squared. Okay. So that's in its factored form. Do you have repeated factors? Yes, x minus 1 shows up twice. So for a repeated factor, you have to use the highest power, which is x minus 1 squared. So I'm going to have, I'm going to talk about this. I'm going to have an x minus 1 squared, but I also have to include the lesser power of that factor. So underneath squared is x minus 1 to the first. Right, so I'm actually going to have two fractions because of the repeated factor. Okay, when you're deciding your numerator, though, you're just going to look at the factor, not its power. So is the factor that repeats linear or quadratic? X minus 1. Linear. So both of those are going to have a constant numerator. So I could do A over x minus 1 quantity squared, so I keep like the highest power of that repeated factor. But then I have to have a b over the lesser power, the x minus 1. And then I also have that x, which is linear, so c over x. If that was being cubed, then I would have an a over x minus 1 cubed plus a b over x minus 1 squared plus a c over x minus 1. And then if I had another factor, I would have d. I just use A, B, C, D in alphabetical order. Okay, so we're going to actually go through today and we're going to solve for A, B, and C. So just real quickly, I'm not going to spend a lot of time on this because this is in the video, but I just want to like remind us, like, what are we doing? Okay, what are we doing? We know about rational expressions like what we have over here on the left, right? We graphed them in chapter 2. Remember when you have to factor, look for a whole, asymptotes, etc. Gage is saying, I loved those. That is not true. Okay, you made a face. All right, but in calculus, this rational function right here is harder to work with for things that we might want to do like integrating in calculus. And so we need to be able to rewrite it into something simpler, which is the sum or the difference of some rational expressions that have like simpler numerators and denominators. Okay? So we are taking these problems and we are breaking them up into this other side. Okay? These are called the partial fractions. Last year in Algebra 2, you practiced going from adding these two things to getting the thing over here on the left. Like, if I were adding these two fractions, I would need common denominators. So I'd have to multiply this by x plus 2 over x plus 2. This one would get multiplied by x minus 3, x minus 3. And then my denominator is x squared minus x minus 6. And in my numerator, if I multiplied this by x plus 2, wouldn't this be 2x plus 4? And if I multiply this one by x minus 3, wouldn't it be negative x plus 4 or plus 3? And then combine the like terms and I would get x plus 7. Okay, so we're trying to like undo the adding now. And that's where our first two steps come in. So we're going to break it up into a partial fraction decomposition. You are going to factor your denominators. You are going to write the decomposition like we just did in the warm-up. Remember, for repeated factors, you have to include the highest power and all the lesser powers below it. For a linear factor, your numerator will be constant. For a quadratic factor, your numerator turns into something that's linear. And when I'm doing linear, I just model it after mx plus b. So like if I haven't used any letters yet, I would write ax plus b. If I've already used an a, but I have a linear numerator, then I would do bx plus c or cx plus d. Okay, just like as I'm going through the alphabet. And then always remember, each new constant has to be a new letter. So don't keep using a because they could be different numbers. Okay, they're not all the same. Okay, here are the three new steps we're going to do together. First one is going to be simplified. Okay, so if you look back at what you did in the warm-up, you've got a rational function on the left, and you've got two rational expressions on the right, and everything that's rational looks like a fraction. So sometimes in class I'm like, oh, don't be scared of fractions. Fractions are our friends, right? Trying to like get you more comfortable with fractions. But then other times I turn that into like, wouldn't you like to not have fractions? Wouldn't that be cool? Like, let's make our lives easier. So that's what step 3 is all about. Get rid of the fraction. How are we going to do it? Multiply by your LCD. What do I mean by LCD? Least common denominator. Hint, hint. The least common denominator is all the things that you factored in the original problem. So like whatever we factored originally in the denominator, that's your LCD. Okay, so you don't really have to think about what your LCD is. It's what's the denominator of the original fraction. At this point, you should eliminate your denominators when you're finished with step 3. So if you still have anything that looks like a fraction, you probably didn't complete step 3 correctly. Okay, so you'd want to go back and fix it. Okay, step 4. Well, now we want to get into the business of solving for these constants. The constants are the capital letters. Like, we don't know what we are, so we're kind of like using a variable to like hold their place. But they, in those partial fractions, they really are always the same number. So we need to find out what number are they. Now, this step 4 is the whole reason this shows up in chapter 7. Because essentially what you're doing when you're solving for the constants is solving systems of equations. Okay, and that's what chapter 7 is all about, right? Systems. This piece right here that I have, this is my hint, is it makes it easier. You don't always have to solve a system. It's a little bit faster. So my hint to you is first try to substitute in the zeros of any factors that you see. So we'll do that in our example, but that can kind of make things move along a little quicker. And then the last step is write your decomposition. After you solve for all the constants, you know what A and B are, then just replace them in your decomposition that you wrote at the very beginning. So it'll look like a numerator over a denominator, but it won't have those A's, B's, and C's anymore. You'll be replacing them with actual numbers. All right. Here we go. We're going to do that first one from the warm-up. X plus 8 over x squared plus 6x plus 8, which we already factored. And did I write it a over x plus 2? Okay, I'll model it after how we did it in the warm-up. But if you had those swapped, that's no big deal. We should eventually end up with the same final answer. Okay, so we don't want to solve it when it's all fractions. Okay. We're going to eliminate all of our denominators by multiplying by the LCD. To find your LCD, just look at the original fraction. Whatever you factored in that denominator, that's your LCD. So I really want to multiply the whole equation by x plus 2, x plus 4. When I do that, I like to multiply each individual term like I was distributing it. Okay, because then that way I can cross stuff off and see what's left over. So like the left side would get multiplied by x plus 2, x plus 4. Grab my plus. And this right side would get multiplied by x plus 2, x plus 4, but on the right side I have two separate things that are being added, so I would have to like distribute that to both of them. Okay, so this is x plus 4, x plus 2, and x plus 4, x plus 2. I'm not trying to get common denominators here. I'm just saying like by multiplication property of equality, I can multiply the whole equation by the LCD, and that's allowed. As long as I do it to both sides, and really essentially that's to all terms, if I distribute. Okay, well, over here on the left, x plus 8, x plus 2, x plus 4, over x plus 2, x plus 4, what happens? You're just left with x plus 8. The x plus 2's cancel, the x plus 4's cancel. We have x plus 8, no more denominator. Great. Doesn't look like a fraction anymore. Okay. On the other side, I'm missing my equals. On the other side, a x plus 4, x plus 2 over x plus 2, only x plus 2 will cancel. So then I have to have a times x plus 4. And then on the next term, it's b x plus 4, x plus 2 over x plus 4. Cancel your x plus 4. You're left with b x plus 2. Okay, so I like to write it with my LCD on every single term. That way I can cross off the things that cancel and see what's left. If you're comfortable just like thinking in your head, I'm multiplying everything, these are the things that eliminate, you can do it that way. But you got to make sure you can do it correctly. Yeah, you're just multiplying the equation by x plus 2, x plus 4. So you're not trying to get common denominators. You're just multiplying by something. Just the numerator. It's like x plus 2 over 1 and x plus 4 over 1. Okay. All right. Now, this is where you could start getting into like systems. Okay. But remember in step 4, my hint to you, because like now we don't have any fractions, right? My hint to you in step 4 for solving for constants was choose x's that are the zeros of your factors. So like over here where a and b are being multiplied by something, what's the 0 of x plus 4? Negative 4. What's the 0 of x plus 2? Negative 2. So we can really choose anything we want for x because x is a variable, it changes. You'll be best served by choosing the zeros of those factors, and we'll see why here in just a moment. Let's let x equal negative 4. Then everywhere I see x, I have to plug in negative 4. So on the left side, negative 4 plus 8, 4. On the right side, I have a, and negative 4 plus 4 is 0. Plus b, negative 4 plus 2. Negative 2. Well, what happens to your a? It's just 0, right? It's gone. So now we have an equation that looks like 4 equals, isn't this really just negative 2b? So b is negative 2. Voila! We found one constant. How can we find the other one? You could do some plugging in, but think about the hint that I gave you when we talked about it. Let's now let x equal -2. We haven't exhausted all of the zeros. So before I start just like plugging in random stuff, I would still go for any zeros of my factors. So let's let x equal -2. Then on the left we have 6 equals a times 2 plus b times 0, which is great because b times 0 is 0. So I really have 6 equals 2a, and a is 3. Okay, this is an example where by choosing the zeros of those factors that remain on the other side of my constants, I don't even really need to solve a system. If I choose correctly, I'll be able to eliminate the a or the b and solve for the other. Now, final thing is, so you know what b and a are, now you gotta plug them back into the partial fraction decomposition. So up here we said it was a over x plus 2, so that's going to be what? -2 over x plus 2 plus 3 over x plus 4. So you got to write your answer. Oh, I got those wrong. 3. A is 3, sorry. A is 3, right? 3 over x plus 2 plus b is -2, right? -2 over x plus 4. Sorry, I can't see all my work on my page. Okay, so let's write that down. 3 over x plus 2. And you can say plus -2, or I'm going to say -2 over x plus 4. You can write it like that. If you had these swapped, it would look like -2 over x plus 4 plus 3 over x plus 2, that's also right. So it doesn't matter what order they're being written. But you will always get -2 over x plus 4 and 3 over x plus 2. Now, on a side note, because this is going to show up in some of our later examples, I told you a hint, right? I said let x equal the zeros. If up here I had chosen something different, like let's say I let x equals 0. Oops. Then I would get 8 equals 4a plus 2b. So that's an equation in 2 variables. In order to be able to solve it, I would need a second equation in 2 variables. So then I would have to let x equal something easy, 1. Plug it in, I would get 9 equals 5a plus 3b. This is like my row 1, this is like my row 2, solved by elimination or substitution, and I would come up with the same answers. So you could choose any x, and then you have 2 variable system, but if you choose x that is the 0, you might be able to cancel out one of the variables, or one of the unknowns. All right, let's do the next one. This was the second one on the warm-up. Did I do a over x minus 1 squared and b over x minus 1 and c over x? Does that look about right? Okay, so we've already talked about how to set up the partial fraction decomposition, right? And if you haven't watched that video, you need to go back and watch that video and take the notes and look at the examples. We're moving on to step 3, which is trying to simplify this. There's a lot of fractions there. I don't really want to try solving that whole thing. So we're going to make it into an equation that doesn't have the fractions anymore. It doesn't have the denominators. So to cancel out all the denominators, you multiply by the LCD. Your LCD in this one is x times x minus 1 squared. So essentially what I'm saying is let me take the whole equation and multiply it by x times x minus 1 squared. I'm allowed to do that to a whole equation, right? Okay. But when I do that, I'm really distributing it to all the terms. So this is times x, x minus 1 squared, times x, x minus 1 squared, times x, x minus 1 squared, times x, x minus 1 squared. I like to write it out on each term so that I can cross stuff out. Okay. Well, on the left side, if you multiply by the whole denominator, then it's all going to cancel, right? So this is gone, and we just have 3x squared minus x plus 5. On the other side, for the a term, the x minus 1 squareds will cancel, but I'm left with ax. In the second term, I can cross out an x minus 1. So I have plus bx times x minus 1. I have 2 factors left over. I can't cross out all the x minus 1s, just one of them. And then at the c term, I can cancel out the x. So I have c times x minus 1 quantity squared. Okay. But after step 3, you should look at your equation, and it should be no more fractions. It's all up in the numerators. You canceled out all the denominators. Okay. What do you want to let x be? What would be good numbers? 0 and 1. Okay, so we'll start with 0, one at a time. Let's let x equal 0. You just sub it in for all the x's. 3 times 0 squared minus 0, that's just 0 plus 5, so we have 5 equals. A times 0, I'm just going to do this for showing my work, right? A times 0 plus b times 0 times negative 1 plus, this would be c times, when I put 0 in, that would be negative 1 squared, won't it? Again, I'm just doing this so I can see my work where I got my numbers. Anybody questions on where 5 zeros or negative 1s came from? Okay. Well, someone said, this one's just 0, right? Gone. B times 0 times negative 1? 0. Negative 1 squared is really just 1, so isn't 5 equal to c? Okay, I found a constant. Cool. Now, you guys told me let's let x equal 1. Make sure when you do anything like over here that you do the exponent before multiplying. So 1 squared is 1 times 3 is 3. Minus 1 is 2 plus 5 is 7. And then I'll have a times 1 plus b times 1 times 0 plus c times 0 squared. Okay. All right, well, b times 1 times 0 is 0. And c times 0 squared? 0. So I really have a equals 7. And you can see on this one, because b had both factors on it, it had the x factor and the x minus 1 factor. When you chose the zeros for those 2 factors, b disappeared each time. So that means in order for us to be able to solve for b, we're going to have to choose an x that's not one of the zeros. So what do you want to let x be? 2, I heard. We'll let x equal 2. Can you let x equal something else? Sure, it does not matter. We should get the same answer regardless of what you let x equal. Okay, so you could say let x equal negative 1, let x equal 3, let x equal 10. I usually try to keep x small. Okay, so now I got to go back up to this guy right here. Remember, do your exponent first. 2 squared is 4 times 3 is 12. Minus 2 is 10 plus 5 is 15. So I'm going to have a 15. And then I am going to just continue plugging into this one, okay, just to illustrate what's happening. So I'm showing my work. So I'm just plugging in 2. I would get a times 2 plus b times 2 times 1 plus c times 1 squared. Okay. So just plugging in that 2 that I think Tyler gave me, just everywhere I saw the x and simplifying a little bit. So I come up with this equation if I rewrite it. 2a plus 2b plus c has to equal 15, which you're like, oh, well, I have 3 unknowns, but we already solved for c, and we already solved for a. So we could really substitute those things that we do know into this equation, couldn't we? Okay, so I'm going to sub in a equals 7 and c equals 5. So this is kind of like feeling more like a system, because I'm like, okay, I had 3 equations, now I'm making substitutions, and I'm solving the system. This is 15 equals 19 plus 2b, so negative 4 equals 2b, and b equals negative 2. So what do we have? 7 over x minus 1 quantity squared plus, nope. I could do a plus negative 2, or I can do a minus 2 on this one, over x minus 1 and plus 5 over x. Did I get that right? Now, if you took the time for those 3 fractions to get common denominators and distribute in the numerator, when you added everything together, it would equal our original problem, 3x squared minus x plus 5 over x cubed minus 2x squared plus x. Okay. Does anybody have any questions before I do my last example? Okay, so think about the first example we did, pretty basic, right? Linear factors, not too bad, solved really fast. Second example we did had some repeated linear factors, so I had to remember to include the lesser power. There was a little bit more solving that I had to do because I had 3 unknowns. So now I'm going to do an example with a quadratic factor. We've got 5x squared plus x plus 27 all over x cubed plus 9x. Step 1, factor your denominator. Take out an x. You're left with x squared plus 9. Does not factor. X plus 3 times x plus 3 is x squared plus 6x plus 9. And then it's not a difference of perfect squares, so this does not factor. So now you can see I have one linear factor, and I have one factor that is quadratic. Can you see the difference between this one and the last one where the square was on the outside, so it was a repeated factor? And now the square is on the inside with my x. It can't be factored anymore. So it is a quadratic factor. Okay. So that means when I do my decomposition, the linear factor will have a numerator that's a constant. So I could do like a over x. But my quadratic factor will have a numerator that's linear. And I always model it after mx plus b. That's linear. And since my next letters would be B and C, I'm going to say BX plus C. So I'm kind of like putting in my letters for M and B. So this is a BX plus C over x squared plus 9. If you have a quadratic factor in the denominator that does not factor, then in your numerator you'll have an x. Okay, multiply by my LCD. That's x squared times, oh, not x squared. That's x times x squared plus 9, right? Well, of course, everything's going to cancel out on the left, so I have 5x squared minus x plus 27. Think about what's left over on the right when you multiply by your LCDs. Your x's will cancel, so you have a times x squared plus 9. Your x squared plus 9's will cancel, and then, like, do you see how you have x times your numerator bx plus c? You need to protect your numerator with a set of parentheses. It's a linear factor now, so you need to put it in parentheses when it's getting multiplied by x. Whether you want to put the x behind or in front of it, multiplication is commutative, so it doesn't matter. So I'm going to write it as x times bx plus c. Just because I usually like one term in front of a binomial. But you can write it as bx plus c times x, that's fine. Just protect it with parentheses. Okay, you got any x's I should use? 0. If I plug that in on the left, I get 27. If I plug that on the right, I get 8 times 9. And then I have a 0 times essentially c, because b times 0 is 0 plus c. But either way, this whole thing is getting multiplied by 0, so it's not there. Therefore, a is 3. Okay, there's a couple of different ways to keep solving, but one of them could be similar to what we did on the last one. You know, you might look at the factor x squared plus 9, but that doesn't have any real zeros. It has imaginary zeros, plus or minus 3i. So if you run out of zeros to plug in, then just start letting x be other things. Since we've already used 0, let's let x equal 1. So that'll be what? 5 minus 1 is 4 plus 27, that's 31. Equals, this will be a times 1 squared plus 9, so a times 10. Plus 1 times b times 1 plus c, so that's really just b plus c, isn't it? And you guys know that a is 3, so isn't this 31 equals 30 plus b plus c? Just by substitution, and then distribute my 1. Anything times 1 is itself. And I would move that 30 to the other side. Subtract, it's 1 equals b plus c. So I have one equation in 2 variables, b and c. In order to be able to solve, I need 2 equations in 2 variables, a system. So what else could we let x equal? 2. Okay, you can let x equal 2. I would choose -1, but you guys say 2, so I'm going to let x equal 2. Because when you do 2, you do have like some bigger numbers, so I just try to avoid that with 1s. But what is that? 5 times 4 is 20, minus 2 is 18, plus 27, 45? Equals a times 13 plus 2 times 2b plus c. And that's 45 equals 39. And plus 4b plus 2c. So 6 equals 4b plus 2c. Oh yeah, I'm substituting a is 3 right here. We've already solved. I do that. So a is 3. I did that right here. Let a equal 3. And I do that right here. Let a equal 3. Okay, so now I just gotta solve a system, right? Like we could call this row 1 and we could call this row 2. So I might take row 1 times -2. -2 equals -2b minus 2c. 6 equals 4b plus 2c. Now you're like, algebra 1. 4 equals 2b, so b equals 2. And then if b equals 2 right here, okay, I could sub it into row 1. Then 1 equals 2 plus c, so c equals -1. Okay, side note, if you used 1 and -1 on those, then this c would have been a -c and you wouldn't have had to multiply. It'll cancel out real nice. That happens a lot with your linears. So I always choose 1 and -1 if they're not already the zeros. Okay, and then the last thing is put all this stuff back. So what did we have? 3 over x plus bx plus c. So 2x minus 1 over x squared plus 9. That's my partial fraction decomposition. Gosh, this is kind of fun, isn't it? If you like algebra, I really like it. I like a system. And these aren't hard systems. They're okay. There are some other really cool patterns and connections you can use to like find A, B's, and C's. So if you want to kind of explore that when you're doing your homework, you know, take a minute and try some different things. You have 6 problems. You're going to take a quiz tomorrow.
Just over 7.
Just over 7:04. I'm not going to be here because I'm driving the van for the math club. So here's what the sub is going to have you do. 5 minutes, chat about your homeworks. So like talk to your groups if there was one you couldn't do. Hand out the quiz. The quiz is 3 questions. How many examples did we do today in class?
Trace.
Each with a different thing we were learning, right? Okay, so be prepared. Okay. And then I think I have like 10 to 15 minutes for your quiz, and then pass out the review. Okay. So the review has 2 sides. I want you to do the first side for Monday. We can do the second side next week. Test on Tuesday. If you're going to be gone tomorrow, see me before you leave. Let me stop my recording.